Example 9. Read example 9 to yourself. Scott, what's example 9 wanting me to find? How high? Now, we've done how high before for like dropping from a cliff. That was d equals VIT plus a half AT squared, or VF squared equals VI squared plus 2AT. So we need to keep reading to decide what approach. How high do we need to lift a 65 kilogram object? They gave me a mass. Remember in kinematics, in those 4 equations on the first line, there was no m's, so I'm not looking at those ones. VF equals VI plus AT. I'm not looking at those. And, what's this 15,288? What is it? This is gravitational potential energy. What's my equation for gravitational potential energy? You may have memorized it inadvertently. Yeah. Probably you'll end up memorizing a half mv squared and mgh during this unit. But do you need to memorize it, Scott? No, I put it on your formula sheet, so if you forget, it's always there. Scott, what are they asking me to find? What variable in this is height? Get the h by itself. Yep. Big surprise. Okay. So the height is going to be the potential energy divided by mg. It's going to be 15,288 divided by 65 times 9.8. I got to put the bottom in brackets on my calculator. And as always, if I sense you're not typing on your calculator, there's a good chance I may call on you to force you to type on your calculator. Good, someone got the message there. Always important. Hast du ein Calculator, Jung? What do I get, Mr. Duick? 24 even? They're not going to work out so nice in your homework. I tried to make these work out nice in the lesson, but I don't care enough to do that for the homework. Scott, units, 24 what? It's a height. Meters. So, where can we apply this? Well, pile drivers are a good example. You may recall when the Golden Years Bridge was being built when you were kids, there was pile drivers going on there for quite a while. Suppose we want a 2,500 kilogram pile driver to hit the ground at 18 meters per second. Eric, what's A asking me to find? What's the equation for kinetic energy? Does not. Go look at your green sheet. And by the way, that's a sloppy mistake to make on a quiz or a test, right? Don't be scared to check your sheet. What's KE? Good. Half mv squared. So 0.5 times 2,500 times 18. Don't forget the squared, Mr. Duick. If we want it to hit the ground at 18 meters per second, how much kinetic energy does it need? Thank you for picking up the hint. Do it yourself, Mr. Duick. 0.5 times 2,500 times, this will probably work out even. Eric, did you get 405,000 joules? Is that a lot? It's a pile driver. It should have a heck of a lot of energy because it's pounding log. By the way, when it hits the logs, it's applying a force over a distance. That's what moves the logs down into the surface, right? 405,000 joules. Okay. Where'd that kinetic energy come from? It came from dropping the pile driver. It came from the potential energy. So how high do we need to raise it? Ella, I think what this is saying is your potential energy at the top equals 405,000 joules as well. But what's my equation for potential energy, Ella J? So you're telling me mgh equals 405,000? So how high do we need to raise it? How would I get the h by itself? Yeah, just like Scott said. Okay. Hopefully you're starting to really see why I pushed that formula manipulation at the beginning of the course. So much easier. H equals 405,000 divided by mg. I could write out the numbers, but this is a lesson and we're cutting corners and it's a Friday, so I'm going to go straight to my calculator. It's going to be 405,000 divided by bracket 2,500. This, I doubt, will work out evenly. Oh, I got a typo. Times 98. What planet am I on? Ella, what'd you get? 16.53, yeah, 16.5 meters. Ella, suppose you're the engineer and you've just come to the job site and you realize, oh my goodness, there's a tree in the way. I can't raise it 16.5 meters. But I still need 405,000 joules of energy. What can we do? What other variable is there in this equation that we could change? Can I change the force of gravity? No. What other variable could I change? You're going to need to get a heavier pile driver. This is some of the calculations engineers will be doing when they're doing soil surveys and all that stuff as well. They will be scoping out how much room do we have to lift something? Is there something in the way? Now, by the Golden Ears Bridge, they probably had unlimited room, but you can imagine if you're in a city somewhere, there might be an overhang or a bridge or an overpass or something in the way. Well, then you better get a heavier pile driver. So we can make all these adjustments, and we don't need to guess. We can calculate them. Okay? A person is running at 7 meters per second squared. No, 7 meters per second. 7 meters per second squared would be an acceleration. If they have a kinetic energy of 100 of that, what's their mass in kilograms? Oh, okay. Emilio, what's this asking me to find? Okay. We found mass in several different ways. F equals what? We found a mass there sometimes. We found a mass in P equals mv, but they gave me kinetic energy. So which equation do you think I'm going to use? Don't write it down. Just tell me. Eric, is KE equal to mgh, or is that a sloppy mistake that we just shouldn't make? What is KE actually equal to, Eric, my friend? A half mv squared. Clearly, man, I should have gone to somebody else. You know what? Jonah, you've handed some homework in. I'm coming to you instead. Jonah, forget Emilio. What's the equation for kinetic energy?
1/2 times m times v squared.
Or as we like to just say, a half mv squared. What are we trying to get by itself here?
M.
Let's see if we can do that without writing out the original equation. So I'm going to put the KE down so I have kind of a reference. What else is next to the m?
Squared.
How would I move the v squared over?
Divide.
Yep. And then there's a 1/2, but I don't see a 1/2. What I see is a times by 1, divide by 2. Dividing by 2, how will I move that over?
Times by 2.
And then timesing by 1, technically, how would I move that over? Divide by, will I bother doing that? No. Okay, here's yet another equation. This one is for mass. Assuming you've read the right equation in the first place, which, wow. 2 times 1,764 divided by 7, don't forget the squared. I might have made this one work out evenly, who knows? Maybe. $72 units. Kilograms. My point is, for either of these energy equations, as far as I'm concerned, I can ask you to find anything. Okay? We saw the video yesterday. What's your homework? I already said you could do 1 through 9. You can also try now, you can add number 10. You can add number 11. You can add number 12. Mr. Durick, are you going to sign them all? I'll skip 13, but you can do 14. I'll assign 15. You can skip 16 because I'm so nice. But 17 is a roller coaster. We have to ride the roller coaster. 17 is so easy that it's tough. I didn't give you enough information to calculate it using a formula. I gave you enough information to calculate it using a pattern. In a few minutes, we're going to go over your momentum test. But first, I think my boss has been standing over my shoulder for a little bit, just kind of sitting there. I better talk to that individual.